In this lecture, we are going to look at sample correlation matrix, which is denoted by capital letter O, where O is used to denote the correlation matrix of a random vector. It is important to summarize the information on correlation in a matrix. The formula for calculating O is ds inverse times S times ds inverse, where ds is a diagonal matrix of S1, S2 till Sp, where S1 is the square root of the sample covariance S11, S2 is the square root of S22, and Sp is the square root of Spp. The sample covariance S is the matrix of sample variances and covariances of p variables. ds is the diagonal of the square root of S11, S22 till Spp in the sample covariance matrix. And ds inverse is simply the diagonal of 1 over S1, 1 over S2 up till 1 over Sp. We're going to find O for matrix X. We have already calculated S in the previous video, which was a 2 by 2 matrix, which is 7 minus 1 minus 1, 4. So from the S, we can find the O. So we know that we can calculate ds by taking the square root of S11 and square root of S22. So we're going to have the square root of 7, square root of 4, 0, 0. From ds, we find ds inverse, which is simply 1 over S1, which is 1 over square root of 7. Here it's 0, 0, and 1 over square root of 4, which is 2. Next, we find S times ds inverse. We have 2.646 minus half minus 1 over root of 7 and 2. Next, we find O, where O is the ds inverse multiplied by the SD inverse. So we have 1, 1, so we have a 2 by 2 matrix. So this is how we calculate the correlation matrix O. Let's suppose we label this as x1, x2. So basically you're finding the correlation between x1 and x2. It is the same as finding the correlation between x2 and x1. So that is why you have this value same as this value. Now you have a negative value, which means you have a negative correlation, and it is 0.189, which means you have a very weak negative correlation between x1 and x2.